Hi, I'm Dr. Karunamurthy from VIT University Chennai campus. I welcome you all for this lecture series on Turbomachines. In the very first lecture, we are going to discuss about the introduction to Turbomachines. Before we start this lecture, let me tell you the relevance of this course for your placement. Here you are viewing an advertisement. This is given by, this advertisement came in Times of India. And here you can see like they are recruiting assistant general manager maintenance for offshore operations, and in this they have mentioned about the roles and responsibilities of the person to be recruited. And here you can see like here it is mentioned like rotating static equipment, responsible for maintenance of rotating and static equipments. So this rotating equipment is what we are going to deal with. Right? This Turbomachines course is about this rotating equipments. Okay, so like in many process plants, we used to have this rotary equipments. So this course is about those rotary equipments, which we call it as turbomachines. So turbomachines can be defined like this. Turbomachines are rotary equipments, and example for this rotary equipments are turbines and pumps and other equipments of turbomachines are fans, blowers, compressors. All this we call it as turbomachines. And within these turbines, we have different type of turbines like steam turbines, gas turbine, and hydraulic turbines. And also these days in the automobiles we use turbochargers to increase the performance of the engine, which also comes under turbomachines. Coming to the overview of the presentation. So in this lecture 1, we are going to discuss about the definition of a turbomachine, classification of turbomachines, and what are the components in a turbomachine. So the turbomachine can be defined like this. It is a device in which energy is transferred between a flowing fluid and rotating element. This transfer of energy can be from flowing fluid to the rotating element or from rotating element to the flowing fluid. And because of this, there will be change in pressure and momentum of the fluid. So this turbomachines basically we classify into two different types, like power developing turbomachines and power absorbing turbomachines. So earlier I was telling you like we have different types of turbomachines like turbine, pump, compressor, blower, fan, etc. In that turbines comes under power developing turbomachines, whereas fan, compressor, pump, these equipments they come under power absorbing turbomachines. Because like with the help of the fluid we used to develop mechanical energy, or we produce mechanical energy due to the movement of the fluid when it passes through this device, which we call it as a turbine. This is an example of a wind turbine. In this case, here we provide electric power to drive this fan, and because of the movement of this fan we are going to have flow of fluid. So we have to provide power for this, so which we call it as power absorbing turbomachine, and this is a power developing turbomachine. So basically we have two different types of turbomachines. One is power developing turbomachine and other one is power absorbing turbomachines. So all types of turbines like gas turbine, steam turbine, wind turbine, hydraulic turbines, they are all power generating turbomachines, because we produce, in this case of power developing turbomachines, mechanical energy is being produced, or we can also produce electrical energy. This is being achieved due to the movement of the flowing fluid. And in the case of power absorbing turbomachine, mechanical energy or shaft power is provided as an input in order to transfer a fluid So which we call it as power absorbing turbomachine. An example for this are compressors, pumps, fans and blowers. So now in here you can see this is an example of a steam turbine. So this turbine in which this is an example for a gas turbine. So here the products of combustion from the combustion chamber, which is coming with high energy, is used to drive the turbine. This turbine contains impeller. So because the momentum with which the fluid is coming is used to drive this turbine. So this we call it as gas turbine, because the medium is going to be the products of combustion from the combustion chamber. And here this turbine, so this indicates a steam turbine. So yes, the steam which is produced from the boiler, this is used to drive this turbine. So before it enters into the impellers of the turbine, we used to have a nozzle. So the purpose of nozzle is to convert pressure energy into kinetic energy. So high kinetic energy fluid which is entering into the turbine is used to drive the turbine. And this diagram shows a hydraulic turbine where the working medium is water. So the water that is being stored in a dam, the potential energy of the water is used for driving this turbine wheel. So the water from the dam, as it passes through the pipeline, and at the end of the pipeline we used to have a nozzle which is having decreasing area of cross section. So this leads to increase in kinetic energy. So the high kinetic energy fluid which hits this turbine is used to drive the turbine. So since the working medium is water, this turbine we call it as hydraulic turbine. And this is a wind turbine where the medium is going to be wind. So the high velocity wind is used to make this blades or the turbine to rotate. So these are some of the examples for power generating turbomachine. And coming to power absorbing turbomachines, so this is a compressor. This is a centrifugal compressor. So in the case of a compressor, air enters at low pressure, and when it passes through this compressor, when it comes out from the compressor, it comes out with high pressure. So that means we are going to impart energy to the fluid, thereby its pressure is going to be increased. So to achieve this turbine wheel, this impeller is going to transfer energy to the fluid. So in order to transfer the energy to the fluid from the compressor, so we have to make this compressor to operate. So normally this will be coupled to an electric motor. So electric motor is going to provide the shaft power. With the help of the shaft power, due to the rotation of this impeller, it is going to transfer the momentum to the fluid, and thereby the fluid gains energy and it comes out with high pressure. So this we call it as a compressor. So compressor is basically, it is a device in which the fluid's pressure is increased. Normally air or some gases will be used. So this fluid gains energy due to the rotation of the impeller that is present in the compressor. And this is a fan which is used to drive or move a fluid. Due to the rotation of the blades, the fluid passes through this. The fluid is being driven by the rotation of the blades of the fan. And here you can see this diagram indicates a pump. This is a centrifugal pump where a fluid enters into the pump, and due to the rotation of this impeller, the fluid gains momentum and it comes out with high pressure. So this is a pump. So all these are all power absorbing turbomachines, because we have to provide power in order to operate these devices. So to operate these devices, we have to provide electrical energy as input. So thereby the fluid comes out with high pressure. And one more type of turbomachine is a turbocharger. These devices are predominantly used in automobiles, where we want to produce more power in smaller volume. Like let us say if you want to have a smaller engine and to develop more power, what we do is that we used to supply air for combustion. And basically there are two different types of engines we have. One we call it as naturally aspirated engine, and the other one we call it as a turbocharged or supercharged engine. In the case of a turbocharged or supercharged engine, the air that is used for combustion is compressed. When you compress air, what will happen is that it occupies less volume. So in less volume we are going to have more amount of air, so more amount of fuel can be burned. When more amount of fuel is burned in a smaller volume, the size of the engine comes down. So that is the advantage. And this turbocharger contains both a turbine and a compressor. This is a compressor part and this is the turbine part. The exhaust gas from the engine is used to drive a turbine, gas turbine, which is coupled to a compressor. The compressor is driven by the turbine. So the compressor takes in air from the atmosphere and compresses the air, and the compressed air is supplied to the engine for combustion. So this device we call it as a turbocharger. Turbocharger contains both turbine and a compressor. So the compressor receives power, mechanical energy from the turbine, which in turn utilizes the waste heat of the exhaust gases leaving. Okay, the compressed air coming from the compressor is sent to the combustion chamber for combustion in the engine. So coming to the parts of a turbo machine, basically we have four different components which are mandatory in a turbo machine. Either it can be a power generating turbo machine or it can be a power absorbing turbo machine. So the very important component in a turbo machine is a rotating element, which we call it as an impeller, vane, or bucket, or blades. Depending upon the type of the turbo machine that we are going to use, this name changes. And this rotating element, apart from the rotating element, we will have some stationary elements. These stationary elements are used to guide the fluid so that it moves in a particular direction, so that we can extract more amount of energy. So these stationary elements, which we call it as guide vanes. So these guide vanes, they guide the fluid to flow in a particular direction, and they will not rotate, so we call it as stationary elements. So, and the third component of a turbo machine is a shaft. So on the shaft, this rotating element will be mounted. Then all these component has to be enclosed or covered. That we call it as a housing or a casing. So for a turbo machine, we have these four parts. One is the impeller or the rotating element. Then to guide the fluid that is flowing, we need to have a guide vane, which we call it a stationary element. Then the rotating part has to be mounted on a shaft so that the shaft rotates. And all these needs to be covered with the help of a casing, which we call it as a housing. This diagram shows a simple turbine, axial flow turbine. When you see the exploded view of this, you can see the different parts of the turbine. So as we discussed earlier, this has a rotating element. This we call as a rotor, where we have the impeller. Alright. Then we have a stationary element. This is what we call it as a stationary element or a stator. Here you can see the guide vanes, which allows the fluid in a particular direction so that we can extract maximum amount of energy from this. And all these are mounted on a shaft. And this is completely covered with the help of a casing. So these are the four major components that is present in a turbo machine. Coming to the classification of turbo machine, we can classify the turbo machine by different ways. Initially, when we started this lecture, we classified like power generating turbo machine and power absorbing turbo machine, which is also one of the classification of turbo machine. So when we classify a turbo machine based upon the energy transfer, then we call it as power generating turbo machine and power absorbing turbo machine. And there are different ways by which we can also classify turbo machines. Based on the direction of flow, the turbo machines can be classified like this. And generally the direction of flow we used to compare with reference to the axis of the shaft. So when we say a turbo machine as axial flow turbo machine, that means the fluid flows parallel to the axis of the turbo machine. And we have also radial flow turbomachine. Basically, when a fluid flows, there are three different directions that are available. One we call it as axial direction, other one we call it as radial direction, and the third direction is called as tangential direction. So these three are perpendicular to each other. So if the fluid flows parallel to the axis of the turbomachine, then the flow we call it as axial flow. Then and if the fluid is going to flow radially, then that type of turbomachine we call it as radial turbomachine. And the third one is the tangential flow. In the example for all these different types of flow are given here, like axial flow pump, axial flow compressor, axial flow turbine are examples for axial flow turbomachine. And in the case of a centrifugal pump, the flow of the fluid is predominantly in the radial direction. So that turbomachine we call it as radial flow turbomachine. And in the case of a Pelton turbine, where we generate power with the help of the hydraulic energy. So in this case, the water power or the hydraulic energy of the fluid is used to rotate or drive the blades of the turbine. So here the fluid hits or strikes the turbine wheel in the tangential direction. Thereby we produce power. So this we call it as a tangential flow turbomachine. And if the flow is a combination of these three, then that turbomachine we call it as a mixed flow turbomachine. In the case of Francis turbine, where the inlet is in one particular direction and the outlet of the fluid is in another direction, so that type of turbomachine we used to call it as mixed flow turbomachine. And coming to the here in this diagram, you can see like this is axial flow turbomachine because the fluid is passing along the axis of the turbine, axis of the wind turbine. So this turbomachine we call it as axial flow turbomachine. Similarly, this is a diagram of a Kaplan turbine, and where the fluid entry is in the axial direction and the exit of the fluid is also in the axial direction. So this we call it as axial flow turbomachine. This diagram shows the direction of movement of the fluid in a centrifugal pump. And when the fluid enters into the blades, and because of the rotation of the blade, the fluid that enters into the impeller, the energy is being transferred from the impeller to the fluid, and because of this the water moves in the radial direction. Means from the center it moves radially outwards. So this is an example for a radial flow turbomachine. And here you can see this diagram indicates a Pelton wheel. So in the case of a Pelton wheel, this wheel has to rotate. To make this wheel to rotate, water is allowed to pass through this pipeline, and at the end of the pipeline we have a decreasing area of cross section, which is nothing but a nozzle. At the end of the nozzle, water comes out with high velocity. So this high velocity jet of water which impinges on this blades of the turbine, thereby it makes the turbine to rotate. So here you can see, so this turbine has a circular shape, and the jet of water which strikes the blades of the turbine is in the tangential direction. This is like a tangent to the circle. So this flow we call it as tangential flow. So this diagram shows this represents a Francis turbine. Here you can see the entry of the fluid is in one direction and the exit of the fluid is in another direction. The water which enters into the Francis turbine, it enters radially. This enters in the radial direction, and as it passes through, it turns 90 degree and it comes out axially. This is the axis of the Francis turbine. So the entry is in the radial direction and the exit is in the axial direction. So since we have two different directions of flow, this turbomachine we call it as mixed flow turbomachine. And we also classify the turbomachine based upon the position of the shaft of the turbomachine. If the shaft is in horizontal direction, then we call it as horizontal turbo machine. If the shaft is vertical, then it is vertical turbo machine. Similarly, if it is inclined, then we call it as inclined turbo machine. In the case of steam turbine, gas turbine, we used to have horizontal shaft. Even in the case of hydraulic turbine also, we will have horizontal shaft. In the case of a Kaplan turbine, normally we used to have a vertical shaft. And these days we are having microhydral power plants, and in the case of microhydral power plants, the turbines that we use are having inclined shaft. And depending upon the position of the rotating shaft, so here you can see like this diagram shows the Pelton wheel, and this Pelton wheel, here you can see like the shaft is in the horizontal direction for a Pelton wheel. So this is an example for horizontal shaft turbo machine, and this is for a steam turbine. In the case of a steam turbine also, the shaft is in the horizontal direction. Vertical shaft, we have already seen the example of a Kaplan turbine where the shaft is in vertical direction. So here we can see like the position of the shaft is in vertical direction. This is a Kaplan turbine. And depending upon the condition of the fluid in the turbo machine, they also can be classified like impulse turbine and reaction turbine. In the case of impulse turbine, the complete pressure drop occurs in the nozzle, and after that the pressure remains same. When the fluid passes through the blades of the turbine, the pressure remains same. Whereas in the case of reaction turbine, even when the fluid passes through the blades of the turbine, we have the variation of pressure or the fall in pressure. So such type of turbine we call it as reaction turbine. Whereas in the case of impulse turbine, the pressure drop occurs before the entry of the fluid into the turbine. We call it as reaction type turbo machine. This difference between impulse and reaction we can explain with the help of a man-boat analogy. So here if you see this case, here there is a person, a man, he is trying to jump from a platform into a boat. So when the person jumps from this platform to the boat, this boat is when the person tries to jump into the boat from the platform, the boat moves in the forward direction, and this movement of the boat in the forward direction is because of the impulse action. And in the other case, let us say the person is standing on the boat and he wants to jump from the boat to the platform. When he jumps from the boat to the platform also, the boat moves in the forward direction, and this movement of the boat in the forward direction in this case is due to the reaction. So